Hello everyone, welcome to Math 153, Statistical Reasoning. Here's a problem that students should take interest in because, they're college students, and this is a problem about college students. Triola's making it relevant. Government financial aid for college students. I'll mention, since we've brought up the topic, make sure you're getting financial aid, right? Fill out a FAFSA. I have been on committees. It's one of the things I like to do. I sit on these committees and people submit applications and we give them money. And there are committees that determine, well, there were 12 applicants. We have 6 scholarships. Who should we give them to? And I like to do that. It's one of my volunteer activities as a professor. But let me tell you what really happens, because you're thinking, wait. Yeah, let me tell you what really happens is we have 6 scholarships to hand out, and we don't get 12 applicants. We get 4. That means we leave money on the table. So if you have not talked to your academic success advisor about scholarships, you should do that. I'm not saying you have to take out a loan if you can afford it. I'm not talking about, whatever, but sometimes there's scholarship money that's just lying there waiting for some student to ask for it. So do that. So what do we find? Why are we interested in this? Because we don't want to pay people who are just milking the system, right? We want them to graduate eventually. So what is the percentage of students who graduate on time, as they say, in 4 years or less? We don't know how to do this one yet. The reason is what we're trying to do is we're trying to find out the sample size. I want to get a 3% margin of error, and I want a confidence level of 99%. How many students should I ask? And what am I going to ask? I'm going to say, are you a student? Yeah, they're students. So it's a sample of students. There's going to be 100 or 500 or 1,000 or 20,000. I don't know how many. And I'm going to ask, did you graduate in 4 years or less? And they'll say yes, or they'll say no. And then I'll have a proportion. I'll have a p hat, and I will use it to estimate p. I want my p to be pretty close. I want my margin of error to be 0.03 or less. So let's jump back to the textbook and I will show you the formula for this. Here on page 307 are the instructions to determine sample size. So this is an important question. We mentioned it just briefly in class, the idea being that you want to interview enough subjects or measure enough subjects that you can calculate your margin of error within some specified amount. You don't want to be too far off, but you don't want to do more than that. If you only need to count 100 penguins, don't count 200 penguins. It wastes research money. Use that for something else. And so we would really like to find out what n should be. And there's a formula for it. It doesn't surprise you that it has a critical value, z sub alpha over 2. It has the sample statistics of success and failure. It uses the margin of error. And so, okay, this is great. You plug all this stuff in. Fine. Why are there 2 formulas? So there are 2 formulas because one assumes that you actually know p hat. And why would you know p hat? Well, because I already caught 100 penguins and I found 28% were male. So I happen to know this. This would be, I haven't even flown to South America yet. I don't have my visa. I don't have a ticket or anything. I'm still sitting in Michigan. And I don't know what p hat's going to be. I'm going to go down and find out. What's the difference between these formulas? One says, I actually know it's 28% are male. In that situation, I would multiply 0.28 times the q hat. That's 1 minus 0.28. And that's the value I use here. Here, I have no idea how many are males. I don't know the proportion. And so what would I do? Well, here's the idea. Maybe 50-50, and you say, why do you say 50-50? Because I don't know anything. I don't know anything. So I'm just assuming it's 50-50. Because if I were to say, well, it's 40-60, well, that assumes I know something. but I don't know anything. Well, if it's 50-50, then when I multiply the 50 by the 50, I get 0.25. And that's the idea here. You are usually better if you do know p hat, because anything, this is 50-50 makes this the biggest value you can ever get, 0.25. And you think about it, you say, well, what if it was 40-60? Well, 0.4 times 0.6 is 0.24, which is a little smaller. That your sample size, the number of penguins you need to count, is smaller. That saves you money. If you knew it was 70-30, well, 0.7 times 0.3 is 0.21. We're saving almost 20% of our study dollars, right? Our value of n shrank a lot, going from 0.25 to 0.21. So how can you know p hat? Well, maybe you did this last year, so you might know. Maybe from a pilot study. I need to do probably 1,000 penguins. I need to talk to 2,000 adults about whether they're comfortable in a car. But let's just ask 100 and get a feel for what the percentage is. That's what they call a pilot study. Or someone's expert knowledge. Someone just knows a lot about this. And then you can use this formula. And if you don't know, then you're overestimating. There's a round-off rule, and we don't need to use it. So there's the explanation behind it. The tricky part is that when we say we want to be within some particular margin of error, so our problem that we were just looking at said be within 0.03. What that means is 0.03 on the left and 0.03 on the right. And that matters because of what I'll show you here right now. So we want a 0.03 margin of error with a confidence level of 99%. Assume that we don't know anything about the proportion of students who earn a bachelor's degree in 4 years or less. We go to stat, we go to proportion, we go to one sample. This is different finally. We go to width, sample size. Power is something we will mention very, very briefly later in the course. I might spend 2 minutes on it. It deserves an entire lecture, but we don't have the time, sorry. Width is what we want to know. So use width, sample size. And this is a strange looking thing. It's like, wait, what? But don't worry about the graph. The graph means nothing to you. All that matters here is you have to put these values in. And most of it's copying. There's one tricky part. They told us to use a confidence level of 99%. So I put that in, 0.99. We also have to know the target proportion. This is the p hat. I know nothing about p hat. So what do I assume it is? Well, it's probably 50-50. So that's why this 0.5 is here. Now comes the tricky part. We need to put the width in. And the width, if you look at this, you say it's 0.03. Yep, it's 0.03 on the right, and it's 0.03 on the left, right? Because we have a confidence interval, and our p will be in the middle of a 0.03 up and a 0.03 down. So what's the actual width? It's double this. It's 0.06. So put in 0.06, and they will tell us the sample size. 1844. You notice, by the way, that this changed. Wait, I thought it was 0.06. What happened? What happened is they rounded up. You always have to round up. And you think, that's not the normal rounding rule. Nope. The normal rounding rule depends on 5. 5 you go up and 4 you go down and something. There's a complication to it. Here, we have to have enough. If the answer were 1843.1, well, there isn't a 0.1 penguin. There isn't a 0.1 student. So you have to ask a whole student, and that's why this goes up. So they've already rounded up. What that means is we're actually more accurate than they said. We said, well, I need to be within 0.06, and we're actually within 0.05998. It's not much of a difference. There wasn't much rounding going on here. But anyway, there you go, 1844, and you put that in. The only tricky part, as I say, is you have to double the margin of error to find the width. 1844, great. We'll spend one more minute. Assume that we've done this before, last year, prior studies, 3 years ago. We find that about 55% of full-time students earn bachelor's degrees in 4 years or less. And I'll mention again, remember these numbers are made up. Has nothing to do with you, has nothing to do with reality. But if we happen to know that 55% is the value we found before, then our target proportion is that 55%. 0.55, we have to adjust our width. It's twice the margin of error that we desire. So 2 times 0.03 is 0.06. We hit compute, and hey, we just saved some research dollars. We don't have to talk to 1,844 students. We only have to talk to 1,825. A substantial, I don't think it's substantial. And that's what they ask us. They say, does it help? Yeah, we went from 50% to 55%. It didn't help much. It slightly reduces. Using the additional survey information only slightly reduces. It's nothing to write home about. And that's how you work those.